All right, day 11. So we get a set of numbers, and every number we want to apply some rules on for each blink. If it's 0, it gets turned into 1. If it has an even number of digits, it gets split in 2, and otherwise it gets multiplied by 2024. So let's say we start at 0. We have 1 stone at depth 0, the number of times we've blinked. 0 gets turned into 1, so then we still have 1 stone at depth 1. 1 gets turned into 2024, still 1 stone at depth 2, but at depth 3, this gets split into 2, and so now we have 2 stones, and then you keep doing that 25 times. So we read the data, want to get the data, split it on white space, and parse each number into a U size. Let numbers be a vec of U size data, and then we want to split it on white space and map each string into a U size. And then we want to apply the rules 25 times on each number and count how many stones there are. So we have to iterate over the numbers and sum them. So numbers, iterate, and then we want to do some mapping here. And then sum that, and then we'll print the sum. And so what we want to do here is that we want to call a recursive function to get the stone count. So we call that get stone count, and we send in the number and then the depth we are looking for. So 25 and then 24, 23 all the way to 0. And we can generate that. I'm using sed, by the way. This we should call depth, or so this would be the number of blinks left to do, and it should return a U size. So pretty simple. If the depth is 0, then we return 1, because then we have 1 stone. Otherwise, we check if the we now have to apply the rules. So if number is 0, then we want to return get stone count. Number should be 1. So 0 gets turned into 1, and depth should be -1. Otherwise, we want to check if it's an even number of digits, so we'll convert it to a string. And then we can get the number of digits by taking the length of the string. And then we want to check if it's an even number of digits. So if digits modulus 2 is 0, then we want to split it in 2. And the way you do that is you take the string, and then you want to take up until digits divided by 2, so half the string, and then you parse and unwrap it. And you do the same thing for B, but you do the dot afterwards, so you get the second part. And then we return get stone count A, depth -1, and plus B. And last rule, if it's no other rules apply, we should multiply the number by 2024. And now if we run this, we get the correct value. And for part 2, it's the same thing, except we should run it 75 times. And even if we run this in release mode, it's gonna run forever. So it's not going to work. And so what is fairly obvious when you see this is that you get repeating numbers. So like this 0 here, like this will in next step be split into 2 0 to 4, and then that 0 will just do the same iteration again. So and we have 2 in 2 places here. So we should use something called memorization, which just means that for each key, which is what we send in here, we want to just save that in a lookup table, so we can just return it. And that is super easy to do. So we can have a memory, it will be a hash map, and we can send this into the get storm count. And so we have memory, and the key should be the number and the depth. And we need to include that in each recursive call. But then we also want to use it. Oh, right. And the value needs to be use-size, because that is what we return. So first thing we do is if memory contains key, and we can define the key. That would be number depth. So if it contains key, then we want to return memory get key unwrap. Otherwise, and then we get all of this. Come on. Otherwise, we need to set this to result. So and before we return this, we should we need to save it in the memory. So insert key result, and then in the end return result. And it is complaining, it needs to be mutable. Okay. And use size I32. And it needs to be the value that is returned. And okay, and then We run it and we get the result. So yeah, fairly straightforward.